Interior designers are responsible for creating the environments that prompt experience and shape mood, engagement, and preference. People spend the majority of their time indoors, within the built spaces designers create. Prioritizing well-being in interior design has been the aim of interior designers who understand the profound effect of the built environment on our psychological, physiological, and emotional well-being. Spaces address ADA regulations in terms of dimension and ergonomics, but do not always address visual interest, visual preference, and mood as conditions of well-being. In recent years, the theory of biophilia has been presented as a solution for what the WHO called the epidemic of the 21st century, stress. A deep awareness of the practical applications of biophilic design practices among interior designers can lead to more interesting and stimulating spaces that enrich our well-being. Human affinity for nature, termed biophilia, has captivated designers interested in designing for well-being. The aim of these designers is to leverage the restorative effects of nature into interior spaces to benefit the well-being of inhabitants. The theoretical framework set forth by Browning and others provokes discussion as to how to apply biophilic design practically. The framework outlines 14 biophilic conditions, divided into 3 categories: natural analogs, nature in space, and nature of space, which could be utilized to reach the well-being effects of biophilia. These conditions are named patterns, following from Alexander's a pattern language precedent. The 14 patterns can positively affect cognitive, psychological, and physiological state of the users of a space. The reductionist view of biophilic design, limited to introducing vegetation through an indoor courtyard or a windowsill planter, is combated in the outlining of the 14 patterns, and in particular through the adoption of pattern 10. James Kensler bemoans what he calls the nature band-aid approach, which seeks to place a ficus in the corner. This trivial change is not sufficient, when a reordering of the space with a true biophilic approach is needed for a real improvement. Pattern 10, complexity and order, under the category of nature analogs, speaks directly to the use of fractal patterns in design to create a balance between boredom and interest. A clear benefit is seen in expounding on pattern 10, since it offers real-world applications that move beyond the simple introduction of living plants or pools of water. The limited understanding of the comprehensive prospects of biophilic design have been an issue that many designers have contended with. Complexity and order, pattern 10, calls on nature's organizational structure in its symmetry, repetition, and pattern. This condition is described as rich sensory information that adheres to a spatial hierarchy similar to those encountered in nature. The mathematical underpinnings of such order can be found in the math of fractals. Fractals were first categorized by Minot Mandelbrot in the book Fractal Geometry of Nature. To judge any geometric pattern as fractal, it must demonstrate certain characteristics. The pattern must repeat, its repetition must happen at different scales, and elements of the pattern must be self-similar. It must also be infinite in its repetition. Characteristics of fractals have been set out by the famed mathematician Kenneth Faulkner to include fine structure or cascade of detail, irregular, hard to describe with Euclidean geometry, self-similar, mathematical or exact, or statistical, natural, can be described in a very simple way through recursion, translation, etc. Biophilic design strategies, including the application of fractal patterns, promise a well-being effect on the inhabitants of space. More specifically, studies show a strong relationship between the statistical fractals and well-being, natural fractals and well-being. As Joey says, quote, "To put it crudely, it is not the tree that causes these emotional responses, but the fractal mathematics of the tree." The self-reported perceived well-being effects of fractal patterns have been documented as an increase in visual interest, visual preference, and mood. Other studies in laboratory settings have proven well-being effects physiologically, as reduced heart rate and diastolic blood pressure, as well as increase in alpha waves of the brain. These findings concerning fractals and well-being have practical implications for design. In fact, real-world manifestations of fractal patterns are seen in the architectural scale, the middle, the decorative scale, the micro, and even in the urban scale, the macro, both recently and historically. Historic examples span geography, culture, and scale. Manifestations at the urban scale can be seen in the African Baila villages. Fractal repetition and scaling is common in Hindu temple design, a clear example of fractals at the middle scale, the architectural. At the micro scale, the interior, fractal qualities can be seen in Islamic patterns, both in the 3D muqarnas and in the 2D tiling. Architecture theorist and mathematician Nikos Salingros highlights important stylistic trends that have affected visual complexity in design. The examples given of fractal design are often overwhelmingly traditional and historic. He traces the contemporary dearth of visual complexity to the living legacy of modernism and the influential thoughts of Ada Flores and Le Corbusier. On this issue, he comments, quote, "Thus they, Adolphe Loos and Le Corbusier, condemned the material culture of mankind from all around the globe, culminated over millennia. While these condemnations may seem actions of mere stylistic interest, in fact, they had indirect but serious consequences." If we are to combine the reflections of architecture theorists around pattern and ornament to those of mathematicians, we could amend the list of characteristics set out by Kenneth Faulkner to describe what we can now call designer fractals. These characteristics would include a fine structure, cascade of detail, irregular, hard to describe with Euclidean geometry, self-similar, whether it be exact or statistical, can be described in a simple way, recursion or translation, etc., intentionally applied through scaled iteration, with the 3-time nested iteration of shapes. If we look to historically recent designs, we see a resurgence of ornamentation. Charles Jenks attributes this resurgence to postmodern thought that brought with it a rejection of dogmas and rigidity that typified modernism and the international style. A few examples referenced of postmodern buildings that embrace ornamentation include the facade of the Alexandria Library, FOA's Ravensbourne College of Design Communications facade, and Toyo Oto's upscale store in Tokyo, Todd's. It can be said that some of the architects and designers in these situations are reacting to the strict modernist style, which could be ascribed as a motive behind Toyo Oto's design. Others are looking to their communities and drawing from their traditional culture in a time where the prevalent style allows for such sources of inspiration, such as in Alexandria. For some designers, ornament and fractals unlock advanced technological tools that warrant exciting new processes, such as FOA's building. However, there is no clear indication that the architects are aware of the well-being effects of this type of perceptible visual complexity, and it is probable that few are focused on the micro scale of the interior experience. An example of a recent project that deliberately targets the visual complexity of the interior experience is Mohawk's Relaxing Floors. The firm 13 and 9, with assistance of Dr. Richard Taylor, utilized research into fractals and well-being as the basis for an interdisciplinary project to create relaxing floors for Mohawk. This project is a flooring solution that, quote, utilizes fractals to give our eyes a break from the digital world and deliver the essence of nature to the contract-built environment. The fractal patterns used as inspiration in these modular carpets were developed using a type of computer programming called L systems. This project is a wonderful example of the interdisciplinarity that manages to link scientific research with practical application. It should be noted that the patterns used are not in conversation with the history of ornament. A practical criticism of the patterns comes from the location of their installation. Since one of the main characteristics of fractal patterns is self-similar scaled iteration, it follows that it is best to have the viewer approach the pattern slowly and discover its detail. This is a hard task to achieve through flooring, and is much easier to achieve with wall covering. I suggest that applying the patterns to walls would be more successful in activating their fractal qualities within space. In my research, I use designer fractal patterns in context within an interior environment to measure the perceived well-being effects of positive versus negative mood, visual interest, and visual preference. The designer fractal patterns used as visual stimuli in my research have been developed through a lengthy interdisciplinary process. The process began by researching many iconic patterns from different time periods and different styles with a global eye. A collection of 50 patterns exhibiting the promise of visual qualities were chosen as a representative sample. The 50 patterns were narrowed down through a collaborative process with mathematics graduate students at The Ohio State University. The patterns were narrowed down to 6 using the outlined characteristics of designer fractals. These chosen patterns were then modified till they satisfied the designer fractal characteristics as much as possible. A checkered pattern was added to the 6 patterns to act as control. These visual stimuli were then used in 2 types of sessions that were designed to collect responses to perceived well-being indicators. The first session enlisted participants in a laboratory-type experiment to rate the perceived well-being effects of the pattern swatches through a forced choice procedure, answering a prompt relating to each of the well-being indicators. The methodology was constructed to parallel methodology used in precedent studies. Whenever a forced choice method was not appropriate, a Likert scale was used. The second session embraced a participatory mindset and co-design activities. The designer fractal patterns were projected over an entire wall within a well-lit room. The participants in the room were asked to communicate their perceived well-being. Several mapping activities were carried out to establish responses to visual interest, visual preference, and mood. Other responses were also collected in the session, such as spontaneous utterances and observable behaviors. I hope for my work to stand in the chasm between theory and practice of design research, and to help fill it. It is important to use the knowledge attained from this investigation to strengthen designers' evidence-based decisions that remain loyal to human-centered design, putting well-being above design dogma and style hegemony.